Hello everyone. So today we study about the next CPU scheduling algorithm, that is the shortage of first algorithm. So start with an example. So here in this example we have given the five processes, their arrival time into the CPU and their worst time. Okay. So in this we have to find the average turnaround time, the average waiting time. So with this algorithm, that is the shortage of first algorithm, we have to select the process whose worst time or the CPU time is shortest as compared to the other processes. So start with the solving this example. So at time 0 we have no process in the ready queue because the process P1 is arrive at time 1, the process P2 arrive at time 2, and the process P3 arrive at time 3, and so on. So at time 0 there is no process in the ready queue, like this. So at time 1, so we have the process P1 in the ready queue and their worst time is 7. So we have to execute this process for next 7 millisecond. Okay. So P1 process P1 is to be executed in the CPU for the 7 millisecond. The time now is 8. Okay, like this. So process P1 completes its execution in the CPU at time 8. Now at time 8 we have to check how many processes are coming up in the ready queue. So at time 8 all the processes are already in the ready queue because these processes, there is a P2, P3, P4 and P5, their arrival time is 2, 3, 4 and 5. So this time is within the 8 millisecond. So now we have to check in these four processes that whose worst time or the CPU time is shortest. So in these four processes the process P5 has the shortest worst time. So the process P5 is to be executed after P1. Okay, and for the time, the worst time for the process P5 is 1. Okay, so P5 completes execution at time 9, and the process P5 completion time is 9. Okay, now we have left with the three processes, there is a P2, P3 and P4. Now in these three processes, there is a P2, P3 and P4. The minimum or the shortest worst time is for the process P2, because process P2 worst time is 2. That is the minimum as compared to the process P3 worst time and the process P4 worst time. So next after P5, the process P2 is to be executed for next 2 millisecond. That is a 9 plus 2 is equal to 11. This one. Okay, so process P2 completes its execution at time 11. So write 11 in the column, that is the completion time in front of second process. Okay, so now we have left with the processes P3 and P4, and now we have to check which process has the shortest worst time. So the process in comparison, in between process P3 and P4, the worst time, there is a minimum worst time is process P3. So after P2, the process P3 is to be executed for next P3 for the 3 millisecond. So process P3 is to be executed after P2, and time for next 3 millisecond, that is 11 plus 3 is equal to 14. This one. So the process P3 completes its execution at time 14. So write 14 in this column. Okay, now we have left with the one process, that is the P4, and lastly the process P4 is to be executed for the time worst time is 8, and 14 plus 8 is equal to 24. Sorry, 22. So the process P4 completes its execution till time 22, that is 22 millisecond. Now we have to find the turnaround time and the waiting time. So we already know that the turnaround time can be found out with the help of the formula, that is the completion time minus arrival time. Okay, for process P1 the turnaround time is 8 minus 1 is equal to 7, and for the process P2 the turnaround time is equal to 11 minus 2, and by doing so we have the turnaround time for all the processes. Next we have to find the waiting time for all the processes, and we already know the formula for the waiting time, that is the turnaround time minus worst time. Okay, so the process P1, the waiting time is 7 minus 7 is equal to 0. By doing this formula, apply this formula to all the processes, and we have the waiting time for all the processes. Next, we have to find the average turnaround time and average waiting time, and this can be find out with the help of by summing up this turnaround time, waiting time, and we get 49.28, and the average we get divided by this the number of processes. So we have 5 processes, so 49 divided by 5 is equal to 9.8. And for the waiting time, that is the average waiting time is equal to 28 upon 5 is equal to 5.6. So by doing so, we can see how the example is to be solved with the help of shortage of first algorithm. So this is all about today lecture. So please subscribe, share and like the video. Thank you.